Alright, hey guys. Today we are going to talk about matter, physical change, and how matter goes from one phase to another, and how it can affect our environment. How does it happen within our environment? So, what in the world am I even talking about? Matter, before I even define what matter is, try to think of how this term would be defined. Rewrite it in your own words within your notebook or your journal or whatever. So matter is anything that has mass, which is the amount of stuff that is in an object that makes it, and takes up space. An example of would not be matter is light. Light has many properties of matter in the sense that it can take up space in a room, but because it has no mass, you cannot measure it. It cannot take a consistent shape. Or you can't weigh it or anything like that. It's just there. Then that's not matter. But anything that has mass and takes up space is matter. And there are many different phases of matter that you'll see. And how do you think these phases come to be? Well, we are going to learn about that with a video that I have. And before we watch this video, what information do you think is going to be in this video, and how do you think it would alter your beliefs on matter? And so, and whatever we learn about this from this video, we are going to put in a anchor chart about matter. So before we do this video, please take out your sketchbook or your notebook, your notebook. And so we'll be prepared for that next activity. And so, alright, in this video, it's titled Phases of Matter and Phase Changes, and this video is by the channel called Moo Moo Math and Science, if y'all want to check it out in your free time. And let's play and let's listen. Don't forget, do your ears listening, eyes staring straight ahead, and hands to yourself as we watch this video. Okay?
In this video, I'd like to talk about the different phases of matter. Matter normally exists as either a solid, a liquid, or a gas. We call this property of matter the phases of matter. The three normal phases of matter have unique characteristics. A solid holds its shape and has a fixed volume. A liquid takes the shape of the container and has a fixed volume. A gas takes the shape of the container but has the volume of the container. Matter can also change from one phase to another when heat or pressure are applied. When matter moves from one phase to another, this is considered a physical change. This triangle summarizes how matter can move from one phase to another. The plus and minus signs indicate if heat is added or subtracted. Let's first go over the changes that require heat. Melting is when you move from a solid to a liquid. This ice is a solid, but as heat is applied, it is slowly becoming a liquid. Evaporation is when you move from a liquid to a gas. As this water is heated, it is being converted to a gas. Sublimation is when a solid goes directly to a gas and skips the liquid phase. Underneath this smoke is a solid bar of dry ice. These next changes result when heat is removed. Freezing is when you go from a liquid to a solid. This snow at one time was a liquid, but as it cooled and became cold, it became a solid. Condensation is when you go from a gas to a liquid. When water vapor in the air hits a cold glass, it will slowly become a liquid. And finally, deposition is when you go from a gas to a solid. For example, this person is scraping ice on his windshield. The water vapor in the air went from a gas in the air to a solid on the glass. So I hope that helps with your understanding of the different phases of matter. Thanks for watching, and Moo Math uploads a new math and science video every day. Please subscribe and share.
Alright. And now that we've watched that video, let's fill out our chart. So don't forget to pull out your notebooks or your sketchbook or your notebooks, and let's fill this out together. So, what is the first phase that that was listed within the video? What information did you gain from the video? And what information did you gain from the video as a whole? Well, the first thing that he said was a solid. And in the video it said that a solid has volume and it has shape. Now, what is he meaning by that? Volume is the amount of space it takes to fill a container. If the amount of space a container would take up within another container. And the shape is, well, that term is pretty much self-explanatory, but those who within science, shape is describing the physical appearance of the container. So whether it is a square container, a triangle, stuff like that. So a solid has volume and has a shape. What objects would you think would qualify as a solid? You can write, and while you're doing this, we can draw some examples within our chart. So I am going to draw a block of ice, and I know that's a bit drawing, but let me just put that right there. But ice is a great example of a solid because it's rigid. When you touch it, it doesn't move. It stays the same shape. But when you put it in a container, it keeps the same amount of space as another piece of ice would. It doesn't change its volume over time, as long as it's kept into a solid. And while I'm explaining this here, y'all can draw your own examples on what you think a solid in these other two sections will be. Solid in these other two sections will be. Try to think of anything that goes into your own experiences on what you think a solid, and examples from these two sections that we're going to go into. So the next phase of matter is called a liquid. A liquid. And a liquid it does have volume, so it can take up a the container, but it has no shape. Even though it takes up it'll take up the shape of the container, but it doesn't have a shape in itself. It can vary. And an example of a liquid would be liquid water. Let me draw a little like glass of water. That's really bad, but so a glass of water is, here's the picture. So a glass of water is a liquid because even though it keeps up the shape of its container, it has no shape in itself. When you move it, when you swish it around in your glass, it can vary. The shape can vary. It can go high and go low. So that's why they're meaning by no shape. But the volume, whatever container that you put it in, that volume is going to remain the same. Is going to remain consistent. So if I put it in a square container versus a cylinder container, the amount of water in both containers is going to be the same, even though it may look different amounts. The volume is going to remain the same. And now our final phase of matter is called a gas. And what examples would you think a gas could be? What is the first word that comes to your mind? Probably oxygen, or the air we breathe. And I'm just gonna do like little like clouds, or smoke maybe from like a campfire. And let me just draw a campfire, and you can see like the plumes of smoke coming out from that. And so a so while liquid has volume and no shape, and a solid has a volume and a shape, gas has neither. So it has no shape and no volume. A gas takes up the shape of its container, and it takes up the volume of its container. And unlike a liquid that you can measure the volume out, you cannot adequately measure the volume of a gas or shape of a gas, because it takes up whatever container you're going to put it in. And as y'all are continuing to draw your anchor chart, I'm also going to put how these would look, how each section would look under a molecular, underneath a microscope, because something makes up these phases of the matter, and that's called the atom. Atoms are teeny tiny little particles that you cannot see underneath, unless you look underneath a microscope. They're so small that you cannot see them under the human eye. And they look like, we're just going to use little circles to symbolize our atoms. So in a solid, you'll likely see a bunch of atoms close together, like almost touching each other. And this is because the shape and volume is so rigid that the atoms can't move. They do not have enough energy to move, and so they just stay still. They're just like in sitting at a birthday party or something like that. They're like people sitting at a birthday party. They're just sitting there, just waiting for something to happen. And so how does a solid change into a liquid? Or a liquid change into a gas? Well, energy has to be added, and usually this energy is added through heat. So think about like fire on a stove or heat from the sun. So as these atoms, they gain heat, they gain this heat, they want to move. They want to move a little bit, but they don't have enough heat to actually like move around. So they want to stick to each other a little bit. But some of the atoms want to venture off by themselves. So this is kind of like how a liquid would look like. A liquid would look like underneath a microscope. And you can see how versus our solid example, our liquid, the atoms are kind of venturing apart from each other. This is because they are gaining energy from the heat. They're getting enough energy from the heat that they want to move around, and so some of them are disconnected from each other, and that's why a liquid has no shape, because the atoms can pretty much move a little bit, but not too much, so that it has a consistent volume. So now let's add some more heat. What do you think? How do you think this heat is going to affect this change from a liquid to a gas? What do you think is going to happen now? Well, the atoms, they're basically going to start going all over the place. Because they have so much energy, they're just hyper. They want to move all over the place. It's like that one kid at a birthday party that he just drank a little bit too much soda, so he has a little bit too much energy, and he just starts bouncing all over the walls. Like that kid, a gas has so much pent-up energy that it wants to move all over the place, and that's why it has no shape and no volume too. And if you were to keep adding more and more energy, the atoms would move faster, and they would get further and further apart until you basically have nothing left. And if we were to reverse this process by adding cold, the atoms, it would do the opposite. It would get colder and colder, and the atoms would start moving slower and slower until it becomes a solid, and they either can't move or they don't move at all. So in this chart, how do you think, and as you keep drawing, how do you think these changes would happen in real life? What instances have you seen using your life experiences? And what do you think is the importance of physical change? Physical change. Discuss amongst your peers. And now we are going to be I'll be showing y'all some actual like visual models coming from the video game Minecraft. So before we do that, I want y'all to put away your sketchbook / notebooks, whatever you got, and again just keep thinking um, like how do you think these changes would occur within your environment? Just think about that, and you can discuss that with your peers as we show this lab simulation. So, alright guys, now that you've put your notebooks away and you're staring at the screen, this is a game called Minecraft. If you haven't heard about it, it's a sandbox game where you can basically do whatever it is you want. And for this first example, you see some lava down here, and as I climb this ladder, you'll see some water buckets right here filled with water. And let me go ahead and add some more water to this thing. Okay, so now, what do you think, how do you think this water will react when I flip this lever? How do you think the water will react to the lava below? What phase of matter do you think this lava will turn into when I flip this lever? Think about it. Okay? Alright, here we go. And let me put a block underneath here so I can stop this waterfall. Alright, so we can see that this has certainly changed. So this block right here, it is called obsidian. And obsidian is pretty much cooled lava. And you can actually see this in real life. What do you think, how would you think you could see this most commonly in realistic situations? Most of y'all would probably say volcano, and you would be correct with that. But there are other situations like that too. So this change from a liquid, which was lava, to a solid, that is called a physical change. In this case, the physical changed. It changed from one phase of matter to another, but it's still the same thing. It's still lava. It didn't change from lava to something else, to a completely new thing. It's just merely cooled lava. So in this experiment, or in this model, we saw that lava can cool down, can be cooled down by water, which can cause a physical change that we can see here. So next example, I'm gonna go in here. Alright, and we got some goats right here, and you can see on their little like fur, they got some thick fur. How do you think this came to be? Well, in real life, in certain like colder climates, they might have thicker fur, whereas in like a savanna like climate, or like a desert maybe, they would have shorter fur. And this is a physical change, because even though it's still solid, it's a physical change because it's changed the structure. So it went from shorter fur to thicker fur, and in like zoology, which is the study of animals, this is called under a different name. This is called a physical adaptation, which is when an animal does physical change in order to survive within its environment. So that's interesting. So how do you think this example over here with the goats is different from this example with liquids changing into solids? How do you think that's different or similar? Think about it and write down some suggestions. And so now our last example is melting of metals, and you usually see this when like a smeltery or a different, like a welding area. So we got a furnace right here, and we got some gold, and we're gonna burn this underneath this furnace to see how will it change, and what do you think is gonna happen? So we got some gold ingot, and so in this furnace, the reason that it changed was because the solid slightly melted, and that is called when it's like this in between. It didn't really change into a liquid, but it also it changed into a lighter version of a solid, and that's called density. That's a type of physical change. Even though it's still the same type of metal, it didn't change into liquid gold. It's still a solid piece of gold, but it just lightened up slightly, so it's more malleable. And if you, in real life, if you were to keep on melting the gold, it would eventually change into liquid gold, which is really interesting. How like in other video games outside of this one I'm showing right here, what other physical changes could you see? And remember, physical change is it changes from one phase of matter to the other while still keeping its consistency, it's still the same object, even though it's changed. It doesn't change from one object to a completely different object. Write down some suggestions, or like just think about some ideas and discuss it with your peers. Alright, so and also within this activity, what is the importance of physical change within the models that I showed y'all today? So now what are we gonna do? We are going to add onto our chart. So take out your notebook again. And we are going to add some other examples right here. So in the first example, what did you see? What did you see happen? So we saw two liquids, which was lava and water, and we saw them change the lava, at least, from liquid to a solid, which I'm just going to put obsidian right there. Right there. And let me see if I can get y'all to see this stuff. Okay, so obsidian is just cooled lava, and it's in the solid section because it's rigid. It has a shape, which was a square, and it has a volume. It kept up the entirety of that space. And we also saw fur changing. So that would be like a solid to a solid, I guess. Or a solid adding on to another solid. if you can think about it that way. And we also saw a solid turning into a less denser solid, and if you were to keep going, it would be a liquid. And within our first, and then with what other thing did you see? Do you think would happen in real life? Do you think the water would evaporate, or changing from a liquid to a gas, and it would become water vapor as the heat of the lava goes down, and it goes into reacts to the lava, or the lava reacts to the water. And so now we're gonna do a lab simulation to show physical change in action, and how the same substance can react differently to different substances. And before we start, and before we gather our materials, I'd like y'all to think of a prediction to this experiment. How do you think a substance like salt would react to something like water or liquid alcohol? What changes do you think would occur? Make a prediction. Do you think it would change? Do you think a physical change would happen, or do you think another change would happen? What phases do you think it would change into, or do you think no change would happen at all? Make a prediction on what will happen within this experiment, and pause the video and make a prediction. And now that you've unpaused this video, I would like y'all to gather your materials for this experiment. First off, safety gear. We're gonna want gloves for our hands, and we're gonna want a mask for our noses, so the vapor from any liquid that we pour into will not overtake our senses, because sometimes that can be a little bit overwhelming for people. And other stuff that we need 2 clear cups so y'all can see what happens, a spoon to mix our solutions, and table salt, and then you're also going to want some water at room temperature, and you're also going to want a cup of water and a cup of liquid alcohol, or you can use hydrogen peroxide. It doesn't really matter. And while y'all pause this video and gather your materials, just think about how these physical change of matter can affect these substances. Just think about it. Okay? I'll see y'all soon when when we're doing this experiment. Alright, so we are back. So first, within this experiment, I've got 2 cups, and you can see they are empty. You can pour down that, and nothing can happen. And so now we are going to put on our mask and our gloves, because liquid alcohol can mess your noses up. Alright, so we got liquid alcohol. This is 70% liquid alcohol, and we're going to pour it in to our container, or our cup. I'll mess this up, hang on. Alright, so I poured it in, and at first first, what is this phase of matter? It's a liquid, right? And why is it a liquid? Because it has no space, and it can takes up the shape of its container. And so now what y'all can do is y'all can, and I'm also poured in our cup of water, and it's the same. It's a liquid. It's the same phase of matter. And so now we take our spoon and we can fill it up with table salt, about as much as it can hold, and we are going to fill it in one of these liquids. So let's start with the water first. Let me do it like this. So let's start with the water first. So you can see, and as I stir it up, you'll see the water changing into like a cloudy mixture. You'll see it change to a cloudy mixture. And look, the table salt's gone. How do you think this happened? But now we're going to go back and we're going to do the same thing with our alcohol. And we're going to see how that turns out. You can do the same thing with different liquids. Just make sure that it isn't flammable, it doesn't explode. Do your homework first to figure out if anything does any of those things, because I do not want y'all to get hurt with this. So we are going to pour, this is the liquid alcohol. We're going to pour this into here. And you'll see I'll stir it around a few times to make sure that it's really in there good. And you can tell that the alcohol, as much as I can keep stirring it, the alcohol doesn't really like the salt. It just stays there. It doesn't really change that much. But you'll notice as I keep stirring it around how the salt is bubbling up, maybe. You might see some bubbles, or you might see nothing at all. It just depends on how you do this experiment. And now what I need to do before we get into our reflection process, I need to clean up for a second. So let me, and always make sure you keep a clean workstation. This is for other experiments. Alright, so as we seen through our experiment, liquid alcohol really loves water. But it doesn't really like, or the salt really loves water, but the liquid alcohol doesn't really like the salt, or the other way around. Why do you think this happened? And why do you think this reaction is a discrepant event, even to me with this? And what unusual happenings happened in your experiment that you would like to discuss? So for reflection, we can go back to where we started at And so when we saw the water react to the salt, was that called a physical change? What is the physical what physical property do you think, or properties do you think is being shown? Well, in my experiment, the salt dissolved into the water. The salt changed from a solid to a liquid as it was being absorbed. And that physical property is known as, well, absorbency. How much of liquid that a solid can intake before it just doesn't want it anymore. How it likes water. Whereas with the salt reacting to the liquid alcohol in this experiment, it showed it did not like water, or didn't like liquid alcohol. And why do you think this change occurred? And this did a physical change occurred within that variable? And if it was, what was the physical property being shown for that? So within that experiment of showing salt water reacting liquid alcohol, it didn't really react to it, but it did form bubbles. So there was certainly a reaction there, changing the solid of salt to a gas, because alcohol was reacting to the salt. And that's a physical change from a solid to a gas, as seen in the video from earlier. When you saw these physical changes happen, why do you think it's important to know why do you think physical change is so important within the visual models? And how do you think these reactions would occur in real life? You can discuss that amongst your peers. For me, for example, you could see that change happening at the beach with salt water happening. Or you can see, like, if you needed salt water to, like, gargle with at night, you could use table salt, pour it into the water, stir it up a little bit. And that's a physical change of absorbency. And now that y'all can pause the video and discuss these questions, try to use your critical thinking skills in knowing and answering these questions. And again, there's no right or wrong answer to these questions. It's just up to your interpretation of this. So now that y'all have unpaused the video, it's time to take your science journals out, and we're going to write down some questions that y'all can answer. Y'all should be able to answer. All right. So when time count to 10, y'all should have your journals out and ready to write. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got your journals out? Good. So I want y'all to answer these 3 questions to the best of your ability. First question is, list 3 aspects of matter y'all have learned so far within this lesson. It can be about physical change, and use your vocabulary. Use your vocabulary terms, like physical change, matter, atoms, phases of change, matter, solid, liquid, gas, stuff like that. And the second question, and y'all can explain these, explain your knowledge either through visual or like pictures, or you can do it through written text, so writing it out. And make sure that you connect these questions to any life experiences you may have had, and prior information too that you may have had about matter before this lesson even began. So the next question you want the answer is two aspects about this lesson that you would like to know more about. So any like data that you're not too sure about, anything that you would like to know more about in time, and we can do like a little research project on it or something, or a connection that you made within your experiment that you're not really too sure of how to answer about. And then finally, what is one question do you have about matter that this lesson really didn't really go into too much detail about, that you're wondering about? Think about it, and make sure you use your vocabulary terms within your answer, and you use it in context with matter and your own scientific thinking, and you can use your experiment as evidence towards why you answer these questions in this manner. So I'll give y'all some time to write down this information in your journal. In your journal, and so now, after y'all have seen the assessment, we're gonna do a review game to see how much you've gained from this lesson, from me explaining and showing the video, and then the experiment at all. So let me pull it up here, and this game it's gonna be fun. So take your laptops out and go to juniorbrainpop.com. The game is Matter Sorter. That's what it's titled. And let me see if I can. All right. All right. So this is called Matter Sorter, and the objective of the game is to sort different types of objects into different types of matter. So you'll see you have solid, liquid, and gas, as we see here. And then we also got a new form matter called plasma. And plasma really isn't. You'll get into this in future grades, and this is not I didn't really explain what plasma is within this lesson, but plasma is like, think about like energy from this energy, what's made of the sun, like the sun rays. Think about it like that. That's what essentially plasma is. And you'll get more into depth with plasma in future grades. But for this game, I want y'all to really focus on what object makes up a solid, what object makes up a liquid, and what object makes up a gas. And really think about how those characteristics come into play here with that. So we will be able to play one round of this before y'all do your assessment. And you only get six mistakes on this. So let's begin. Hit start. So, what is water? Can you answer that? Of course y'all can. This is liquid. Whoops. I didn't mean for that to happen. So what is oxygen? Well, oxygen is a gas. What is milk? Well, milk is, of course, a liquid. Well, what is flame? This one's a toughie right here. I think that's... Nope, it's not a gas. We'll have to go that one next time. So what is a rock? What type of matter is a rock? Well, that's a... that's a solid. What type of matter is a diamond? That's also a solid. What about a neon sign? It may seem like a solid, but it's really a type of plasma. That's one of the types. So carbon monoxide, what type is that? Is that a... And then helium, that's the air that you use to fill up balloons. And what's that? A gas. Now here's the flame again. Now flame is actually plasma, because it's heated up so much that it can't, the atoms are all over the place. And lightning is also plasma, which is something I didn't know about. So and we're just gonna complete that. If you want to complete more levels, you can within your free time. So, what did you learn? What did you gain from playing that game? What other? How did seeing those pictures and sorting them? How did they? How did they? What object did you not expect to be sorted with certain phases of matter when interacting with this game, and explain your reasoning best on that. And what questions really like challenged you and broadened your understanding on matter to begin with? And so now what are we gonna do? We are going to I'm gonna pull up. So this is y'all's assessment, and it should take y'all no time. There are some short answer questions on here and multiple choice and all that. And this should be going over the basic gist of how certain types of matter can change and how properties of matter can come up. So I'm not going to go any of that stuff. It's up to y'all to take that assessment and answer the questions to the best of your ability. So for review, so review matter is anything that takes up space and has mass. And we learned from our chart right here that matter can come in all sorts of phases, solid, liquid, and gas, and each phase has certain characteristics, which I explained. And so with meeting our target, that y'all observed how objects can physically change and how it can affect the environment, that y'all observed that through our experiment, and through y'all should be able to explain how physical changes can react, can change when interacting within our environment. So, for example, like lava cooling underneath a volcano, or ice freezing in the cold. It's reacting to its environment, but it can also react to changes outside of the environment, like a person making a drink. They might melt ice in their drink. The heat's caused from the liquid itself, whatever the liquid that the person puts in there. Or a person might make gas by mixing some chemicals, in a lab somewhere. So really think about how do you think these changes would occur? And once you do your assessment, you can discuss what you learned from this lesson. What did you gain from it? Were there any spots that were difficult for you to understand with how I explained it? And how did you obtain, evaluate, and communicate information about properties of matter and changes that occur over time involving different phases of matter? So this is the end of this video and this wrap up. And after the fact, I would like y'all to discuss about what I've just said before, because this is a really interesting concept, because even if you have the same substance, it might cause different reactions to other objects. And when you do your experiment at home or at school or wherever, try to come up with alternatives to doing the experiment. Try to investigate with other types of matter, like other liquid. You could try other liquids. You could try other you could try interacting with solids with the liquids, as long as it doesn't blow up or anything, because I want y'all to be safe. And that is it, and I'll see y'all in another lesson sometime. Goodbye.